This is project 3 video number 2, the one in which we program it up, and fire up the editor. I'm going to call it function. Returns nothing, so I choose to call my return variable nothing. Equals plot. I think we're plotting the voltage across resistor 2, so I'll call it plot V2, and I believe it was R1, R2, and V. And I'll put the end for my function there, and I want to make sure that's what it actually was. Oh, it's VR1, R2. So I'm going to check the project handout, make sure I got that right. Yeah, V, R1, R2 in that order. So V, comma, R1, R2. R1, comma, R2. Plot V2 as a function of all that. And was it V2? Yeah, plot V2. So R3, I set up a bunch of values of R3 from 0 to 10 R2. That's what they wanted, from 0 to 10 R2. So I go tab over, and R3 equals linspace of from 0 up to 10 times the value of R2, and I wanted to try 101 of them. See if that looks smooth. And just a quick check. Plot 0 to 10 R2. Okay. And then the V2 is equal to V dot slash. So it's I think it's easier to look at this formula. Okay, I'm going to try to type that in. V2 equals V dot slash 1 plus R1 times, and I think it was 1 over R2 plus 1 dot slash R3, because R3 is an array of values rather than just a single value. And I think I need another parentheses there to close out this one right here, the one in the division sign. I seem to be spreading this thing out a lot. That's enough. I think I'll put semicolons there. Check to make sure I type that in right. V dot slash, and then in the denominator I got that all in parentheses, 1 plus R1 times, in parentheses, that sum of reciprocals. So V all over 1 plus R1 times, in parentheses, that sum of reciprocals, and yeah, it looks just like that. Alright, and then try plotting R3, comma V2. You go plot X, comma Y. So this will put V2 on the Y-axis, which I'm supposed to be plotting V2 on the Y-axis because it says V2 versus R3 for values of R3 from 0 to 10 times R2. So let's try plot R3 V2. Plot R3, comma V2. And I'm going to save that. I'm going to do Control S, and it calls it plot V2, and then I gotta browse to where I want it. And then click Save, and now I have to move over here to where I want it, where I put it. So I'm going to go My Documents, Project 3, and there it is, plot V2. .m. And then I'm going to try plotting. I go 10 volts, 10 volts, comma, let's say 1 ohm, comma, 1 ohm. And what do we get? Oops, it's plot V2. Let's see what crops up. So it says the voltage across V2 goes up, and it gets higher and higher, and in the limit as it gets really big, it approaches the voltage across the battery. Is that right? No, it approaches half the voltage across the battery. That's what it looks like anyway. Let's take a look at that again. Yeah, maybe it's still going up and up. I think I want to try this too. I want to see what it looks like if I go 1,000. I better remember to change that back, because that's not what the project was, but gotta do something to check it. And the plot now looks like it goes up to 5 volts. I see. Actually, that makes sense. So let's change that back. Pretty sure that makes sense. So that was just supposed to be to 10. Control S, and then plot that, and yeah, it does seem to be approaching 5, and then I proved it really is approaching 5, which is half the voltage. Let's look at this circuit to see if that makes sense, that it would eventually go up to 5. So R1 and R2 are both the same. I chose to make them both 1 ohm in my example. So when this goes to infinity, it's as if it's not even in the circuit. I let it go up to 1,000 ohms. So that's not really infinity, but it's very, very large compared to R1 and R2. And then if I could just go around the circuit, then it's as if V3 is gone. It's an open. That whole part of the circuit from here to here is gone. I yank it out. I do not replace it with a straight wire. I just yank it out, and then as I sum the voltages, I have the voltage across the CD of EMF minus V1 minus V2 equals 0. V1 and V2 are whatever the one current is. If this is out of the circuit, that's just one current times the resistance. So if the two resistances are the same, then V1 and V2 are both going to be 5 volts. So, you know, I'd have 10 with my choice of calling this 10 volts. So 10 volts minus 5 volts minus 5 volts is equal to 0. And then in the beginning, I would expect if this is very close to a straight piece of wire, then as these currents split up, none of it. Oh, actually, if this is 0 ohms, so how things get started. This is 0 ohms. That's like this is a straight piece of wire, so the voltage between here and here is 0, and so all the voltage gets dropped across R1, and no voltage gets dropped across R2. In other words, the change in the voltage as I go around the loop would be 0 there, because it's the potential difference between the red and the blue conductor, and I made them both the same conductor. If I make R3 0, that is, at 0 I'm turning it into a straight piece of wire. So that's what I got here. It started out at 0, and then and the limit is R3 got larger and larger, got closer and closer to 5. So it does make sense. I think If I recall correctly, we were expecting, from the expression I got for this, I was expecting that as R3 got bigger, that would make this number right here smaller, which makes the entire denominator smaller, which makes V2 get bigger. So as R3 gets bigger, V2 gets bigger. Starts out at 0, goes to 5. I guess it has to get bigger somewhere along the line. But it just gets steadily and steadily bigger as I make R3 bigger and bigger, because that makes this number smaller and smaller, which makes the denominator monotonically smaller, making V2 monotonically bigger. I mean, it just keeps growing in one direction. It doesn't go up and down. Okay, so I'm actually pretty confident in the result. I've made a couple of checks on it. Haven't really proved that it's perfect, but seems to be working. Make sure, let's try 12 volts, 222 ohms, and 333 ohms, some standard values for resistance. And I'll get a different plot, and it goes to a different voltage, but at that same kind of behavior. Okay, I think I'm happy with it. I'm going to call this a wrap for project 3, video number 2.